Modern naval warfare rarely allows for second chances. When a threat appears on radar, the critical factor for survival or lethality is how fast the distance between launcher and target can be closed. That specific calculus is what drives the BrahMos. Once launched, this cruise missile holds a sustained velocity of Mach 2.8 to Mach 3.0, roughly 3 times the speed of sound. At those speeds, it operates as the fastest active supersonic cruise missile in the world today. Pushing a projectile to this velocity compresses a defender's reaction window to mere seconds, leaving air defense systems with little time to compute an intercept path. In the late 1990s, India's defense establishment sought a platform. To engineer it, India's Defense Research and Development Organization formed a joint venture in 1998 with Russia's NPO Mashinostroyenia, pooling their top-tier aerospace and ballistic resources. The resulting platform took its name from the geography of both nations, drawing its first syllable from the Brahmaputra River in India and the second half from the Moskva River in Russia. The resulting system is a physical synthesis. It represents 2 separate nuclear-armed militaries combining their highest-level engineering into a single shared strategic platform. This technical overview illustrates how the missile achieves its top speed through a 2-stage propulsion architecture. The sequence begins with a solid propellant booster rocket at the base. This provides the initial thrust to punch through the sound barrier before dropping away. Once the booster detaches, a liquid-fueled ramjet engine engages. Unlike traditional jet engines, a ramjet relies on forward velocity to ram incoming air into the combustion chamber. The air compresses naturally, mixes with fuel, and ignites for continuous thrust. This specific engine design allows the BrahMos to keep accelerating and maintain its top speed through the entire cruise phase, making it incredibly difficult for standard ship-based anti-missile networks to track and intercept. As it approaches the target, the missile enters its terminal phase. It switches to an active radar homing system, a fire-and-forget mechanism that autonomously tracks and locks onto moving targets without needing further guidance from the launch site. Even before the warhead detonates, the sheer physics of the impact are devastating. A 3,000-kilogram object slamming into a hole at Mach 3 generates enough kinetic energy to shear a destroyer in half. The initial challenge for Indian engineers was taking this heavy system and adapting it for deployment across multiple military domains, ultimately creating a complete tactical triad. On land, the system is deployed via mobile autonomous launchers. These heavy trucks transport 3 missiles at once, concealing themselves in complex mountainous terrain. At sea, the missile is heavily integrated into the vertical launch systems of modern Indian destroyers, frigates, and even submarines. For the air domain, engineers stripped 500 kilograms of weight from the missile, creating the BrahMos-A, which can be dropped directly from the underside of a Sukhoi Su-30 MKI fighter jet. Modifying the core weapon for land, sea, and air deployment meant it became a flexible, omnipresent deterrent capable of striking from anywhere in the battlespace. While the engineering provides the capability, the way India chooses to share this technology is now altering regional power dynamics. Historically known as one of the world's largest defense importers, India has initiated an Act East policy, pivoting toward becoming a proactive exporter of advanced military technology. This export strategy is highly calculated, designed to push back against China's rapidly expanding maritime footprint and port infrastructure across the Indian Ocean. The first major milestone of this pivot arrived in January 2022, when India secured a $375 million contract to supply 3 shore-based BrahMos batteries to the Philippines. By supplying advanced anti-ship capabilities to nations with overlapping territorial claims in the South China Sea, India is utilizing its domestic engineering to impose immediate strategic complications on Chinese naval operations. That strategy is now accelerating. At the recent Shangri-La Dialogue in Singapore, India's Defense Secretary confirmed the signing of an estimated $629 million deal to supply the missile system to Vietnam. During that same summit, officials also noted that a similar procurement pact with Indonesia is currently in the final stages of negotiation. These exports are designed to facilitate a specific military doctrine known as Anti-Access Area Denial, or A2AD. For a country like Vietnam, integrating the BrahMos allows them to create a high-low layered missile shield. Using the 290-kilometer range of the Indian system, they can project wide, overlapping threat rings outward from their coastline and deep into the South China Sea. Operating inside those threat rings means hostile naval assets face immediate targeting from multiple shore-based vectors, making coercion and area dominance unacceptably dangerous for even a numerically superior fleet. As the export network grows, the platform itself continues to evolve. With software and propulsion upgrades, engineers are currently extending the missile's effective range past 450 kilometers. Simultaneously, research is well underway on the next-generation BrahMos 2. By replacing the ramjet with an advanced scramjet engine, developers are targeting hypersonic speeds between Mach 7 and Mach 8. The BrahMos platform has moved from a domestic procurement project into a shared deterrent, providing Southeast Asian partners with the technical means to maintain their own territorial claims in a contested Indo-Pacific.